Providing mobile access to more kinds of devices, more people, in more places, requires creating an entire platform for mobility, more robust wireless coverage, and superior security and policy enforcement. The traditional solution, overlaying appliances, servers, and management software on wired networks, has meant more cost, complexity, bottlenecks, and single points of failure. Here's how Aerohive's distributed architecture simplifies growing your network. Every access point is intelligent, aware of other access points, and shares in processing network traffic. Every access point acts as a firewall at the edge of the network, enforcing policies before the data hits the network core. Layer 2 and Layer 3 roaming is handled efficiently and securely by access points that share information. The result? A better mobile experience, superior security, scalability, simple upgrades to the latest Wi-Fi, no bottlenecks or single points of failure, no license costs. Every access point, whether you have 2, 200, or 20,000, comes fully loaded with every enterprise feature, automatically adding computing power, coverage, and redundancy. The network is a self-healing wireless mesh that is service-aware, meaning users' devices don't have to be individually configured to use network services. Network management is centralized and cloud-based. Access control is context-based, not port-based. Service can be monitored across Wi-Fi and wired networks, routing, firewalls, and VPNs. Your users want to work anywhere, on any device. Make it simple with a self-organizing, service-aware, cost-effective architecture from Aerohive. Here's where to learn more.
GoNet Systems Wi-Fi access points, GoBeam, are designed to perform in noisy urban environments. GoBeam access points are equipped with an antenna array of 4 elements. When a client requests Wi-Fi access from the multiple return paths, the GoBeam access point identifies the best direction for that specific client. The antenna array is then used to create a narrow 30-degree beam in the direction of the client. Here is how beamforming works. Each antenna element transmits the Wi-Fi signal at a different phase shift. The beam forms in the direction where the signals combine, steering the signal in the desired direction. When interacting with multiple users, the GoBeam access point quickly steers the signal between up to 250 clients. When compared with Omni Wi-Fi access points, beamforming access point deliver a number of key benefits in outdoor Wi-Fi deployments. The concentrated energy of a focused beam goes 2 to 8 times farther than an Omni antenna. With specialized channel filters, it also provides multipath fading protection and interference immunity, and lowers the interference between different cells, reducing air pollution and improving the overall system performance. GoNet Systems XRF beamforming technology provides an additional 12 dB in transmission, 6 dB in reception, 5 to 8 dB in diversity gain, and 20 dB improvement in noise immunity.
Hello everyone. Well, today on a chilly Sydney morning I'm going to show you my antenna. This is my only antenna. It works from 60 meters through to 6 meters, and all it is a vertical pole. Hope you can see that. It's about 4.5 meters high, and the reason it works over such a wide range is because of this FC40 ATU. Now it's capable of tuning from 1.8 to 54 megs, but with this size pole it can only go from about 5 megs up to 54 megs. Now just to show you how I've got this set up, if you look in the ground here, all it is a piece of PVC pipe put into about 100 kilograms of concrete, so much too much for this application, but at least it's not going to move. And then I just use one of the PVC caps that you can get and just drilled a hole in it and put just a 25mm or about a 1-inch piece of steel pipe in it. Then goes up here, and if I can just show you there, all that happens is it's just a PVC 20mm conduit with a wooden dowel rod in it, and I just slide that into the pipe. Now I can actually take this whole pipe out just by loosening off this cap and pulling it up, and then it'll come out. Now I use all sorts of little bits and pieces. These are bits of bicycle handlebar which I cut into sections and use those as spacers. I use a lot of cutting boards. If I can just show you down here, I hope you can see that okay. There's just some old chopping block you can just buy at the kitchen shop, and they're great. They're really strong, they're good insulators, and they can be used for lots and lots of things. Now what I've done here is I've just put an SO239 connector there, and then I've just wired it up to a couple of binding posts, so I can put a coax cable in there, and then here I can take some wires to the vertical. I'm not using that configuration at the moment because I'm using the ATU. And then this here is the ground plate. I just bought a cheap stainless steel pot and I cut out the bottom of it, and then just made sure it was nice and smooth. I used sandpaper to sand down the sharp edges so it's all quite safe, and then I just drilled a whole pile of holes in it and just used some brass nuts and bolts, and then just some wing nuts, and then I can just put my radials on it as required. This here is just the vertical, and all it is it's just a 1-inch aluminium pipe, and I just used a whole pile of them together, telescoped one inside the other, and I just slide it over the top of this 20mm PVC tube with the dowel inside it. It doesn't fall over, doesn't break because it's very flexible, so in a strong wind it'll blow around, but it won't actually break. Now I'll just go and show you my my radial system. Give you a quick walk through the garden. Now what I use for radials is these things here are pardon me, these things here are fiberglass rods, and they're used for electric fences, and this is an electric fence insulator. So all I do is I just slide the rod over, I put a rubber band so it won't slide back up, and what these are, this is just some tubing which is used for irrigation, underground water irrigation. It's pretty cheap, and I just cut it up and throw it over. It just makes it not so visually stunning, so to speak. And Or just go back. And they all just terminate on this ground plate. Now the FC40 has a control line, which is this, and these are the connectors, the coax cable. I made this control line extension out of old Cat5 cable, which is just standard network cable, but a shielded cable is much better. So use a shielded cable and also put some ferrite suppressors on it, and I think you'll find it'll work very well indeed. Certainly works very well for me. So I hope that was interesting for you, and good antenna constructing.
Alors, nanostation 2 est tout à fait en haut, et TP-Link 2424D tout à fait en bas, donc qui n'est pas branché, mais la nanostation elle est branchée. Donc le test sera effectué donc en vue directe vers à peu près ce que vous voyez devant vous, donc autrement dit les montagnes, voilà, donc la ville qui est là-bas, donc qui est loin de 6 km ou 5 km, donc selon Google Maps.
Hello everyone, Rob here. Today I just wanted to show you everyone what I've been doing with this little vertical wire inside a squid pole. If you have a look there, and you'll see that it's just a straightforward old wire, and what I did was I replaced the tape measure cable with the wire. So as you move it in and out, just like a tape measure, the wire goes in and out. Now this is a second one I did just to illustrate what it is. And here's the squid pole antenna. It's about 4 foot long in its collapsed state. It ends up being 7 meters long. And this is what it's like inside. So as you can see, it's nothing special. It's just the tape measure, and what I've done is I've put in some copper tubing, beaten and so forth, and I have 3 contact points, and I hope that, well, not I hope, it does, it will actually make contact on at least one of those 3 points, and probably at least 2 during operation, and so there'll always be a good contact. And all I do is just put the back cover on, of course, later on, and it's done. You'll notice there's a high voltage porcelain connector which I'm using there, and I have a little cover, excuse any shakiness, which just goes over there, and that will cover it up, and I just have to put down those particular wing nuts, but you can see that that's the antenna when it's actually all put together, and this is what it looks like. Try and get the whole thing in. There we go. So now to deploy it, all I do is lose a few washers, and in here I just have a little drawstring, and that way I can just pull out the smallest, hold on, just got to get it in my hands here, the smallest one of these, and out it goes. And then it'll actually go out to the entire 7 meters, or about 23 feet length. And then all you do is connect up an antenna tuner, a remote antenna tuner to here, and away you go. It can of course, you can of course lock it at any particular position in its travel, and that will also actually work fine. By the way, if anybody's wondering, this particular cover here is the base from an old halogen light that failed, and so I repurposed it into this. There's nothing special about the tape measure, it's just sitting in there at the moment, and if you look inside you can just see there's a wire which is down there, and that wire, it's a bit hard to see, but that wire is actually making contact, and it's just spooled around there, and I'm just using the same spring that came with the tape measure, and that's why I used the tape measure, because it was too hard for me to make up some sort of return spring, so I might as well use the one that's already there. I'm using a 10 meter tape measure because that way the spring has plenty of flexibility left in it. If you use a tape measure that's too small, then the spring will max out before the antenna does. This antenna is 7 meters, 23 feet, so I used a 10 meter tape measure. Anyway, so there we go. I hope that helps people out a little bit, and yeah, we'll go and have some performance checks in a future video, and I'm going to do a few comparisons in field strength between it and my small magnetic loop. And my small magnetic loop is currently right here. Can't really see it, but there it is. It's wrapped in plastic. And so there's my small magnetic loop. It's just for storage at the moment, but later on we'll do a little shootout between a 7 meter high vertical and a small magnetic loop on 40 meters up, and we'll see how that turns out. Anyway, we'd like to wish everybody a happy new year. It's now 2013, or 2013, and I hope everybody has a prosperous and happy one. 73s.